All right, so this is notes 2A. This is solving linear equations. And we're going to go through some steps. I want you to write down all of these steps to make sure you have them in your notes, and then we'll go through a few examples, and then you'll be able to do your work afterwards. So we're going to follow this process when we need to solve equations. And remember, solving equations means they have an equal sign in them. So step one is always to look and see if we need to distribute. So we would distribute first and make sure to distribute the negative sign if there is one. Okay, and I'm going to highlight, because you need to remember this, is you need to distribute first. All right, so if you see distribution in a problem, go ahead and do that. Step two is to combine like terms on both sides. So that would be 3x plus 4x, or 5 plus 2, or any combination of that. So those like terms. Okay. Third step is to make sure you get all your variables on the same side. And then what you're going to do is complete the necessary steps to finish the problem. All right, so here's some examples that we're going to go through together and try these out. All right, so example 1, we have 2x plus 8 equals 6x minus 8. So we go through our steps. So first we need to see if we need to distribute, which the clue to that would be there's parentheses. I don't see any parentheses, so we don't need to distribute. The second step would be to combine like terms. So if I look on both sides of the equation, so if I look here and here, I have an x term and a constant. No like terms to combine. Over here, again, an x term and a constant. No like terms to combine. So the next step would be to get the variables all on the same side. So what I'm going to do is I'm going to move this 2x by subtracting it. So when you move things from one side of the equation to the other, you do the opposite. If you're adding, you subtract. If you're subtracting, you add. If you're multiplying, you divide, and so forth. All right? So there's that. And so these 2's go away, and then I have 6x minus 2x, which is 4x. And I leave everything else that I have on that side of the equation. So I have my variables on one side. Now I want to get all of my numbers to the other side. So to do that, again, I do the opposite. So I have minus 8. I'm going to add 8 to both sides. And I'm going to get that 8 plus 8 is 16. And I get that equals 4x, because these go away. Now the opposite of multiplying is dividing, so I'm going to divide both sides. Divide by 4, and I get x equals 4. So that is my answer, okay? And I took up a ton of room, so we'll do another example lower down. I'll write the next one smaller. Okay, so next example is negative 6x minus 20 equals negative 2x plus 4 times 1 minus 3x. So when I look back at my steps 1 to distribute first. So I'm going to go ahead and do that, because what I have over here is I have a parenthesis with a number outside, so I have to distribute. So I will make my rainbow. I'll multiply the 4 times both of those things. So what that gives me after I multiply is this stays the same, 6x minus 20 equals negative 2x plus 4 minus 12x. Okay? Because when I distribute, you multiply. 4 times 1 is 4. 4 times negative 3 is negative 12. Now, second step says combine like terms. So if I look over here, all right, I have an x term and a constant. No combining needed. Over here, though, I have these two. I have a negative 2x and a negative 12x. So I'm going to put those together by doing what it says. It says a negative 2x minus 12x. So what that ends up being is, so this stays the same, negative 6x minus 20 equals, and some of you like doing the line down the middle, equals negative 14x plus 4. All right, so now I have no more like terms to combine. So what I'm going to do is I'm going to move my variables all to one side and my numbers to the other. So what I'm going to do is you can do more than one step at one time. So I'm going to look and see. So I have this 14 over here. The opposite of negative 14 is plus 14. So I'm going to add 14x to both sides. And then since I moved my x's to the left, I'm going to move my numbers to the right. So I'm going to add 20x or 20 also. And I'm going to be left with negative 6 plus 14x is 8x equals, those 14s go away, these 20s go away, and then I have 24. And then the last step is I do the opposites again. So I'm multiplying this 8 times x, and the opposite of multiplying is dividing. So I'm going to divide both sides by 8, and I'm going to get that x equals 3. And that is my final answer. All right? So, doing another example, I'm going to go down to these last two. We'll do 4 examples today instead of 6. We're going to do this one. This one's a little tougher, but I know you all can do it. Negative 3x, oops, not plus, minus 1 plus 8 times x minus 3 equals 6x plus 7 minus 5x. Okay, a whole lot going on in that problem, but I know that you can get it done. So what I'm going to do first is I'm going to follow my steps. I'm going to distribute first. And I have 2 things to distribute, both the 8 and, or the negative 3 and the 8. So don't forget to carry the negative with you. So that would be negative 3x plus 3 plus 8x minus 24. And that's just multiplying those things together. Negative 3 times x is negative 3x. Negative 3 times negative 1 is a positive 3. 8 times x is 8x. And 8 times negative 3 is negative 24. All right, so now I'm going to write out the rest of my equation because I haven't done anything with that. Now what you need to do is look for like terms. So over on this side, I've got a negative 3x and an 8x. Now remember, you can only combine like terms on the same side. Even though I have x's over here, they can't go with the x's on the left just yet. So I have those two to go together, and I also have another pair. I have constants, so those go together. All right. So when I do that, I'm going to do negative 3 plus 8, which is 5x. And then I'm going to do 3 plus negative 24, which is minus 21, equals x plus 7. Okay, so all I did was combine those things together by adding or subtracting, depending on what they say. My next step is to move all my variables to one side and all my numbers to the other. So if I look over here, I've got an x over here. So the opposite of adding x is subtracting x. So I'm going to subtract x from both sides. And I'm going to get my numbers to the other side. So I'm going to add 21 to both sides. All right, and then what I'll get is 4x equals, because those go away, 28. And the opposite of multiplying is dividing. So I'm going to divide both sides by 4. And I will get x equals 7. Okay? All right, so those are 3 examples. That goes through all the different steps that you would have to do. Now we're going to go over some weird cases that you might experience. Okay? So we're going to do this one. We have x plus 3 equals x plus 3. So if you notice on each side of the equation, it's the same exact thing. So if I were to go through and look, and if you have the same thing on both sides of the equation, the exact same thing, every number you can think of will work for that equation. If I were to plug in 5 plus 3 is 8, and that would equal 5 plus 3, which is also 8. So when you see both things on the same side of the equation, or if you get to a point and you're done and you get x like 8 equals 8 and it's true, that means your answer is all real numbers. In other words, every number is going to work for that. Okay? Now, here's the second case. I'm going to do this. I'm going to put 3 times and I'm going to make a box and I'm going to say equals 0. Now you need to figure out, like, is there any number that I can fill into that box that's going to make 3 times something equals 0. There's only one number that works, and that happens to be 0, and this is why. So if I have 3x equals 0, because really an x just means any number, the only number that I can multiply times 3 and get 0 is 0. So x is going to equal 0. Okay, don't overthink this one. Okay, so don't overthink. Sometimes we forget that 0 can be an answer. All right? And the last case is going to be this. X plus 3 equals x plus 5. So I'm going to think in my head, is there any number that I can add to 3 and add to 5 and get the same answer? There isn't. Same thing applies. If you were to get down to the end and you got this, 3 and 5 are not equal to each other. So the answer to that is no real solutions. All right? Those are those 3 special cases. Those are funky. You might see them as you do the work. And if you do, that's fine. You can go ahead and just know that there are different answers for that.